Okay, so I'm just doing question 24 from these three questions here. Sent in by a student. This is x minus 1 on x to the power of 6. And we want the term that is independent of x. Now, if we expanded this out and pretended this was x and this was y, we would get this pattern we're quite familiar with, which is x to the power of 6. 6c6 plus 6c5 x to the power of 5 y to the power of 1, etc., 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 all the way across. Now, what I'm looking for in this case, because this is x and this is 1 on x, and we know they're going to occupy the positions of x and y, they will be multiplied by each other. Now, because we're going to be multiplying this pronumeral by a fraction with the pronumeral on the denominator, there is a potential that they can cancel each other out. Now, to make the term that is independent of x, we need them to cancel completely. So that will only really occur when we split this 6 into the power of 3 and the power of 3. And we would get that when we got to 6c3. And that would become 6c3 x to the power of 3. And this one will be negative 1 on x to the power of 3. Now, the only thing about this that's a bit weird is that this is going to be a negative because of this odd power here. So if we applied the power to this, this would become negative 1 on x to the power of 3. This would be x to the power of 3. And of course out the front we've still got 6c3, whatever the heck that is. I did bring my calculator, so 6c3, so 6c, probably should know this off by heart by now. Yeah, there we go, 20. 6c3 is 20. So these cancel each other out. But remember, when you cancel in this fashion, you end up with x to the power of 3 on x to the power of 3, but this was a positive times a negative, so this is negative. When you cancel it, you don't get 0, you get 1. So this is all of this here becomes negative 1, multiplied by this 20 becomes minus 20. Okay.